Let me start the lecture then. Yeah, so about the lecture, 2 days, and next week's topic is this one. I already put this on the e-learning site. So we are going to learn about lambda expressions and LINQ, which is a very cool technology in the .NET framework. I also uploaded the slideshow here, but first I have to open the slideshow from last week because I didn't finish it yet, but there is a strong connection between delegates and lambda expressions. So this is not a problem. Okay, so this is the slideshow about delegates, and I did not explain the last topic in this slideshow, which is about anonymous delegates. Yes, so what this is about. We use delegates to reference methods, and typically we use those method references as a parameter. So we pass a method to another method. Let me show you an example in our previous project here. So for example, just look at this instruction here. I call a method, generate output, and I pass another method as a parameter. So this is another method. Here, the generate output method receives the parameter, and inside the method, this method is called back. So this is what we call a callback method. Okay, if you look at this source code here, let's focus on this dump to label method. You can see that I reference this method only once, only from here, nowhere else. So it's, how to say, it's quite a waste to introduce a name for a method because you want to name something. You want to assign an identifier to something, in this case to a method, if you want to call the method from several locations from your source code, right? So this is why the identifiers make sense. But now I call it from here, from one location. So it's quite a waste to introduce a dedicated identifier and introduce a separate method. This can be avoided by using anonymous delegates, which means a delegate without a name, used only once. So this is what we need now. And well, anonymous delegates look quite funny. If you look at this example here, let's find out what it is about. So first of all, what is log? Log is an event. You can see it here. So I introduce this variable log, which is an event. You see here, we use a declaration of a delegate type variable log. And this is how we subscribe a method or another method to this event. So log SQL and send SMS are identifiers of two methods in my source code. So this is the basic way to subscribe a method with a name to an event. But if I use those methods only once, only from here, I can also use an anonymous delegate, which means that basically I just put the method exactly there where I use it. I embed the method at the exact location where I'm using that method, where I calling that method. It looks quite funny because there is the method does not have a name, only the keyword delegate stands there. But otherwise, it's a full-fledged method. It has a, you know, a parameter list. It has a body with instructions. It doesn't only have a name. So let me show you how this works. It's quite easy. So here I want to exchange this reference to this method with anonymous delegate. How it can be done? So first of all, I'm going to get rid of this method because I don't need it. I don't need a separate method with an identifier. Rather, I have to embed the method without the name at the exact location where I'm using that method, which is here with this extension. Instead of the name of the method, I have to use this keyword delegate. That's it. It's done. It looks really ugly. I guess you agree. It looks really ugly, but it makes sense actually. I call this generate output method and I pass this anonymous method to it. You see, and it compiles and it works actually. Let me show you with another method like, okay, this one, okay, the next one. So this method dumps the output of the program to a combo box, and I'm going to embed this very method at the exact location where I'm using it, which is here. Here I use the delegate keyword. Okay, let me just format my source code because in this way it's a little bit nicer, and that's it. If I execute my program, it works as before. So far the combo box is empty. Now I'm going to dump the output to this combo box, so it's filled with the output. Okay, and don't forget now this anonymous delegates is responsible for filling that combo box. No question, as far as I can see. So these are the anonymous delegates. They are pretty ugly, but pretty effective. Okay, I will show you that anonymous delegates can be used for so many purposes. But first, if you don't mind, I would switch to my next slideshow. Which is about lambda expressions. Okay, lambda expressions. What do you know about lambda expressions? As far as I remember, you haven't learned about lambda expressions with Mr. Kushper. Am I right? You have not learned about it with Mr. Kushper. Am I right? Do you agree? Guys? Yeah?
We learned a little.
You learned lambda expressions?
Yeah.
Okay, so what do you know about lambda expression? How do they look like? I guess you know that you have to use a special arrow symbol. What does this arrow symbol look like? So could you type it in the chat window, please? So you learned or you did not learn about lambda expressions? This is a question. No, this is not. Yeah, no, well, this is it. Oh, sorry. I sent my message to Shigi, but I want to send it to everyone. I wanted to send it to everyone. Yeah, so this is this double arrow. It's not that double than the arrow typed by Om. Anyway, this is how it looks like. This is a lambda expression, sorry. So you learned about lambda expressions. Okay. Let me talk a bit about the history of lambda expressions. So lambda expressions were not part of C# at the beginning. Only in C# 3.0 lambda expressions were introduced. But if you look at this picture here, delegates were already introduced in the very first version of C#. This shows that delegates are really important. They are really basic tools in programming. Anyway, during the years of in the history of C#, the language was developed along the very well planned line. Actually, here the higher level plan is to make C# as declarative as possible. As you know very well, C# is an imperative language. We learned about this in the previous semester, but during the past years, C# was extended with more and more declarative tools, such as generics and also lambda expressions. Lambda expressions are quite declarative. This means that, you know what declarative means. It means that you don't really have to implement each and every instruction to solve a problem. You only have to declare the problem in some way, for example, as a lambda expression, and then the system, the framework, will try to solve the problem. So you only have to declare the problem. The rest is done by the framework. This is the goal, the future goal, and lambda expressions are part of this plan. Also, language integrated queries were introduced in C# 3.0. Actually, this abbreviation LINQ is an abbreviation for language integrated queries. I think I will talk about them next week. They are really cool. They are really easy to use. Whenever you want to query from a list or from a dictionary or from a database table, you will see they are so nice to use. But today I don't think I will have enough time to talk about them, but I will talk about lambda expressions now. So what are lambda expressions? Here is the answer. Lambda expressions are anonymous delegates. You have seen anonymous delegates. You have seen what they look like. They are ugly, but effective. Since they are ugly, Microsoft decided to introduce a nicer syntax, a more intuitive syntax, as you can read it on the slide. So here is an anonymous delegate. Basically, if you look at it in this example, this delegate receives a string parameter, and it decides if this string parameter starts with the letter S, capital S, and returns a bool value, true or false. So this, the very same anonymous delegate can be translated to a lambda expression like this. And those are equivalent to each other. I guess you agree that the lambda expression version is much nicer and more intuitive than the original version. Okay, so if you compare those two, you can see that lots of stuff has been removed from the anonymous delegate. Let's start at the beginning. So first of all, the keyword delegate was removed. There is no need for that. Of course, we know that this is a delegate. Why to put the keyword there? Let's just remove the keyword. Then this type string was removed. Why? Because you know the C# compiler is smart enough to infer the type of the parameter from the source code, from the context. So this is an automation in the C# compiler. Whenever you use a lambda expression, you don't have to specify the type of the parameter. Just put the parameter's name there. Okay, then of course we can remove the brackets because anonymous delegate always use those brackets, so there is no point to put them there. Let's just remove them. Also, we can remove the return keyword because most of the cases a delegate, an anonymous delegate, returns something. So the return keyword stands there almost every time. Let's just remove the return keyword and keep the most important part, this expression. Let's keep it. This is what is important to specify. Okay, and what else? Yeah, let's just remove the semicolon at the end. So basically, we removed everything which are unnecessary or trivial. And also important, we put the double arrow between the parameter and the expression here. And this is the lambda expression. Okay, so if you are ready, let me show you now how to turn my anonymous delegates like this or that to lambda expressions. It's really easy. So first of all, if you remember, we can eliminate the delegate keyword. Then we can eliminate the type of the parameter because the type of that parameter will be inferred from the context. It can be inferred easily. By the way, we can eliminate the parentheses around, you know, the parameter list, and then what's next? The double arrow. After the double arrow, we can remove the brackets. So I can remove the brackets here, and I can remove the semicolon. Here I am. It compiles, and it works. Of course, I think this is about dumping. Yeah, dumping the output to a label. Okay, it works. See? Okay, let's do this for the other anonymous delegate. I remove everything which I don't need. I put the arrow here and keep the essential part. That's it. Does this work? Not yet, but now it is supposed to work. Yeah. You see? So this is how it works. Lambda expressions are just actually syntactic sugar, so they are sweeter than anonymous delegates, but actually they do the same. Okay, then. Okay, let's continue, or should I do something else? Okay, let me show you something before I continue. I slightly changed the graphical user interface of this project. I've put this list box here. So I hope you remember this project is about storing real estate data. I have real estates, for example, buildings or farmlands, flats, and etc. So when I execute my program, I want to see all the real estates here in this list. Actually, in the program starts with opening a text file. Where it is? Where is it? Here. So the program starts with opening this text file, reading all the real estate data from the text file, and actually this object of a container class is filled with all the real estate data. Inside the container class, we have a list with the real estates, and there are also some high-level methods or properties. For example, what is this? Our container class can calculate the average area of farmlands, or it can return the most expensive real estate. Anyway, now what I would like to do is that when I push the start button, I would like to list all the real estates in this list. This sounds quite simple, but actually it is not. Why not? Because this is what I am supposed to do. I have this list box. This is the name of my list box, LST Real Estates. And I have to fill this list of items by adding each and every real estate object to this list. So I would need to add the first real estate item here, the second, the third, and so on. This is already impossible in this current project because, you know, I implemented the container class with this private list. So the list is private. I cannot access this list. I cannot access the elements of that list from another class. So now I will show you how to solve this problem in a nice way. And this solution might seem a little bit complicated, but this will be a nice solution. So what I would like to do is that I would like to extend my container class with a new public method. Why? Because from this other class, I can call only public methods. So I need a new public method to call inside my container class. Okay, it should not return anything, and let's call it with let's call it in a fancy name like execute for each elements. This is a very fancy and long name. Okay, what I would like to do, I would like to pass something to this method. I'm not telling you what exactly, not yet. Then I would like to start a loop which traverses all the elements of my real estates list, which is, you know, private. And then I would like to call this method, which I passed as a parameter, with all the items. So basically, I would like to execute a method passed as a parameter for each element of the list, like this. So basically, what I need here is to pass a method. You know, for this, we need a delegate. So basically, I will pass a delegate as a parameter, and I will call it back from my container class. This will be a typical callback method. Last time I was talking about the importance of the callback methods in modern software. So callback methods are used everywhere in real life. Okay, let's keep it short. I need to introduce a delegate, actually a public delegate, which I don't know, returns nothing. Let's call it action to execute. This is the name I picked. And actually this will be an action which I want to execute for each elements here. So those elements are actually real estate. So I want to choose a delegate which expects a real estate parameter and executes some actions on it. Okay, so I already explained this last time. I use this delegate as the type of that parameter. Let's call it action. And now I call this action here with the item as a parameter. Okay, again, to sum this up, I introduced a method inside my container class which can receive a method as a parameter. I call this method action. And I call back this method inside of this method. This is a typical usage of a callback method. Okay, now the most important part. I'm going to use this new method I just implemented. So inside my container class, I introduce this public method. So I hope I can access it. Yeah, I can. And now I have to pass some action to execute, an action which should be executed on all the elements, all the real estates inside the container object. So what is this method? It's easy. I already showed this to you. I want to add each and every elements to this list box one by one. Okay, so the action is that I choose my list box. It has an items list, and I want to execute the add method for each and every element of my container object. So what's the problem here? Okay, this is not okay. Okay. Okay, I know what to do. Okay, so I have to implement a method And now I intentionally use an anonymous delegate, which receives a real estate, and this is what it does with this real estate. It adds this real estate to the list box. Yeah, exactly. So this is what I need. I need a method which has a real estate parameter and does some action. Why? Because this is how I declare this delegate. It must have a real estate parameter. Sorry. So here I'm using an anonymous delegate as expected. Okay, let's execute it. This is what I wanted to see. I wanted to list all my real estates inside this list box. Sorry. Okay, let me summarize what I did again. So inside my container class, I created a new public method which can receive a callback method as parameter. This callback method will be executed on each and every element of the container object. In order to pass a callback method, I really need to define a delegate because I have to know what the parameters for this method should be, what the return value should be. This was part of the Kahoot quiz. This is how we can use this public method, and this is how we can pass a callback method to this method. So now I intentionally use an anonymous delegate with the proper parameter and with no return value, you see? Meanwhile, if you have any question, don't hesitate to raise it. Meanwhile, let me simplify this anonymous delegate to what? To a lambda expression. We already did this before. So we can erase the delegate keyword, we can erase the type of the parameter, then let's introduce the double arrow and let's just keep the most essential part here. So this also makes sense. Just look at it. Now I would like to execute something for each and every element of my container object. This is what I'm going to execute for each and every element. If I have an element X, I add it to the list box, to the items of the list box. So it is so easy to read. It is so easy to understand, especially in the form of a lambda expression. I hope you agree. And of course, it works the same. Okay. Okay. Okay, then let me show you something else. You know what? This is what I want to implement. Now, in the list box, I have lots of real estates. I would like to sort them. For example, sort them based on their prices. Okay, in a ascending order. How to do this? Well, it's not that easy again. Since what I already know that inside the container class, I'm using this list. And you already know that the list class provides a sort method. I already talked about this several times. So a a list have a sort method, which I could call, but I can call it only inside the container class because this list is private. I cannot call this sort method from outside, from my form, for example. This is not possible, so I cannot call it from here, for example. How to solve this problem? As always, I must introduce a new public method, which I will call from here, from outside. Okay, let's call it public method sort, I don't know, sort elements. It receives nothing, and then what does it should do? It just calls the sort method of this private list. That's it. So basically, this is how you can solve always the problem. You create a new public method which calls something private inside. Okay, let me do that now. Before listing all the real estates in my list box, I call this sort elements method from my form. Okay, let's see. Okay, it does not work. And sorry for the Hungarian error messages, but actually you are supposed to know what the problem is here because we learned about this before. No. Yes, we did. Yeah, the problem is that this poor sort method doesn't really know how to order our real estates. It doesn't know if real estate should be ordered by name or ordered by price, whether in ascending or descending order. So this is something I should declare, right? Back to this picture. I should declare the way how elements real estate should be ordered, should be sorted. I don't want to implement a sorting method because a sorting method is already implemented inside the .NET framework. I only want to declare the ordering logic, the sorting logic behind this sorting algorithm. Anyway, fortunately, the sorting method inside the list class have multiple parameterizations. And the second parameterization is of great interest now because it receives a delegate. Please meet this delegate from the .NET framework. It calls comparison. Actually, this is a delegate I also mentioned in my slideshow here. You see? So this is a delegate in the .NET framework, which you can pass to this sort method. This delegate basically tells how to compare two elements in your list. In this example, we have a list of cars, so I have to implement how to compare two cars, X and Y. Now, in this case, we compare them by their ages. So I have to do something similar here. I have to pass a delegate which compares two, not cars, but real estates. So basically, this delegate have to real estate have to receive two real estates like R1 and R2, R2D2, and then inside the body of this anonymous delegate, we have to compare those two real estates. Based on what? Well, it's up to me. I wanted to compare those two real estates based on their prices, where the easiest way to compare them to call the compare to method of this uint type. This is the easiest way, and whatever the result of this comparison is, I just return it from this method. That's it. So here I pass basically a method as an anonymous delegate to the sort method. This delegate declares how to compare two real estate objects, R1 and R2. Of course, you can choose another way of comparison. You can compare their names, you can compare the area of the real estates, whatever you want. Now I intentionally chose the price-based comparison. Okay, let's execute it. It works. As you see, all the real estates are ordered, are sorted based on their prices in an ascending order. Okay. I hope it's okay for you as well. Yeah. Of course, you can choose, as I told you, you can choose this expression if you want. For example, if I want to order the real estates in a descending order, I can put here the minus operator, then they are sorted in the other way around. Okay, I hope you understand what is going on here. Okay, now again, I have an anonymous delegate here. It is really ugly. So let's just translate it to a lambda expression. How to do that? Just remove all the unnecessary stuff and let's keep the expression there. I'm ready. Am I? No, not really. I get compilation errors here because I didn't show you yet how to use several parameters. Now the lambda expression have two parameters. So far we use only one parameter, here or there or there. Now we have two parameters here. So this is the general rule. You can use lambda expressions with as many parameters as you want. When you use only one parameter, then you don't have to put the parentheses around that parameter. But if you use 2 or 3 or 4 or no parameters, you must use the parentheses. That's the only problem here. So basically I have to keep the parentheses around my parameter list, and that's it. Does it work? It does. Okay. You know what? Let me show you how easily such a piece of source code can be altered. So for example, now let's suppose I would like to order the real estates based on their IDs. This is the ID here in front. This is a very fancy ID. And I would like to put those in an alphabetic order. How to do this? It's so easy. Each real estate has this ID property, and they are the ones which I compare to each other. Okay, if you look the list with special care closely, you can see that the elements are ordered based on their IDs in an alphabetic order. So This is so easy to alter such a piece of code. It's super easy. I hope you agree. Okay, let me give you some background information. You might have asked yourself why such expressions are called lambda expressions, where this name comes from mathematics. There is a kind of calculus in mathematics, which is called lambda calculus. I looked for this term, this expression in the internet, and I found this definition, what lambda calculus is about. If you read this definition, you can easily see that, yeah, basically lambda calculus is about anonymous functions, methods, anonymous delegates. So basically, this statement also proves that lambda expressions are actually anonymous delegates in disguise. Let me give you also the general rule of how lambda expressions can look like. So as you already know, there is always this double arrow in the middle. There is also left-hand side and right-hand side. The left-hand side is actually a parameter list for the lambda expression. You already learned that it can consist of either a single variable or several variables between parentheses or no parameters. But in this case, you also have to use the parentheses. I showed you this at the bottom of the previous slide. Actually, you can also use parentheses for a single parameter, but this is not a must. You can eliminate the parentheses if you want, so you can save 2 characters if you want. Okay, what about the right-hand side? The right-hand side, oh, sorry. Here I have to translate everything to English. So you can use a single expression if you want. Actually, this is what we used all the time. Here I use a single expression. I use a single expression here as well. So this is the most common case when we use only a single expression. As you might know, as you might, how to say, find out, this is actually a shortcut for this method body. So when you want to return a single expression, you should write this instruction between brackets. But this is so common that you want to return a single expression that you can just simply eliminate the return keyword and also the brackets and keep the expression only. This is always what we did, but don't forget, actually this is just an abbreviation of such a method body, return, and this also works. So this is the long version of this. Of course, it can happen that you want to put several instructions, multiple instructions on the right-hand side of your lambda expression. This is something you can also do, but in this case, you definitely must use the brackets around. So again, on the right-hand side, you can use any method body you want with multiple instructions, but in this case, you really have to use the brackets around. Okay, so this is the general syntax for lambda expressions. Whew. Okay, let's see how much time I have. I have no idea. Anyway. What's the situation in other languages? Believe or not, several programming languages provide lambda expressions. In Java, there are lambda expressions, but it's quite interesting that they appeared in Java later than they appeared in C#. Lambda expressions were introduced in Java 8, which is not that old. The only difference here is that the arrow is a simple arrow, not a double arrow, but that's all the difference compared to C#. In Python, there are lambda expressions, definitely, by using another syntax. In Python, you have to use the lambda keyword in front. Then you can enumerate all the parameters. Then you must use a colon, and then the expression follows. Actually, this syntax really is really similar to the syntax that is used in mathematics, in lambda calculus. If you are interested, just look this up, how lambda calculus, what syntax lambda calculus uses. I can tell you it's pretty similar to the one used by Python. In other languages, well, here I mention some other languages like C++, PHP, and JavaScript. As far as I know, they don't provide lambda expressions. They only provide anonymous delegates, but anonymous delegates are provided by each of those languages and almost all the languages, all the modern languages nowadays. Okay, back to our project. So now I would like to show you something which makes even easier for you to work with delegates, anonymous delegates, callback functions, lambda expressions. Let me come back to this delegate I introduced here, action to execute. If you remember, I introduced this delegate because I wanted to pass a callback method to this other method. So whenever you define a new delegate, first you should look for a similar delegate inside the .NET framework. I already mentioned that there are delegates in the .NET framework already. I mentioned that in the .NET framework there is a comparison delegate which can be used with the sort method. So it's quite likely that the .NET framework also provides something which is very similar to this delegate I introduced. If the .NET framework provides something similar, I definitely don't need to introduce my own delegate. So let's try to figure out if something similar is provided by the .NET framework. And actually, it is. There is an action delegate in the system namespace, which we can use here. But we face a problem here. This compilation error tells us that we cannot call an action with one parameter. You see, this is the problem. I'm trying to pass a parameter to this action, but it's not allowed. Why? Because it says here that an action has no parameter. So I could call an action only like this. But this is not okay for me. I really want to pass a real estate as a parameter to this action. So how to do this? Well, the action delegate has a generic version, you know, with those funny brackets, and this version has also 16 versions. Okay, I have 10 minutes left. 16 versions. 16 versions with 1 or 2 or 3 or 4 or 16 type parameters. That's crazy. So let me talk about this action delegate in the .NET framework, because I have a separate slide about it. Okay, this delegate, or in other words, this set of delegates can be used for representing methods with 0 or 1 or 2 or 16 parameters, which does not return anything. So the return type is void. Actually, this is what I need here. I really need, you see, I really need to represent a delegate which returns nothing, void, and receives one parameter. One parameter. Okay, so what to use? Which action delegate to use here? The one with one type parameter. So I really have to specify here what the type of that single parameter should be. This means that I want to execute an action which receives a real estate parameter, only one. And you see now it's done, it works. Of course, if I use some other type here, then this action expects an int parameter, and I get such an error message. So I really have to put the type of my parameter there, real estate. So this is an action which receives a real estate as a parameter and returns nothing. Okay, you want to see if it works? I guess it does. Yes, it does. Whew. Again, the difference here is that I'm using a built-in delegate. I'm not declaring my own delegate because there is no need for that anymore. Okay, so please meet the action delegates again. You can parameterize them with several ways. For example, if you look at the examples, by using this lambda expression, the first one, actually I can represent an action with one parameter, right? This lambda expression has only one parameter. The type of this parameter is not really specified, so it can be either string or int or byte or float, whatever is can be passed as a parameter to this console writeLine method. The second example, in the second example, the lambda expression receives 3 parameters. So definitely I need an action with 3 type parameters, where the parameter types, well, they depend on the context. So for example, here X and Y could be integers or bytes or U shorts, whatever you want. But I'm really sure that the type of T must be a text box, because here I want to set the text property of T to some string. I just want to demonstrate that the action delegate is compatible with almost all lambda expressions of this kind. Okay. Exactly. So I have 5 minutes left. Therefore, I would like to talk about 2 more slides. There are further very useful built-in delegates in the .NET framework besides the action delegate. So please meet the func or func delegate. The func delegate is actually the same as the action delegate, but it has a return value. You know, func stands for function. Functions return something, some value. So this is the only difference between an action which does not return anything and a function which returns something. If you want to use a function, you definitely need to specify the type, the return type. This is now represented by this tr type parameter. So if you specify only tr, then your function does not receive any parameters, so you have 0 parameters, and you return this type. If you want to use your function with 1 parameter, you have to specify t1, this type here, and also the return type. And you can keep going till 16 parameter types plus 1 return type. If you look at those examples, I think they are quite self-explanatory. Let's see the first one. Here in this lambda expressions, we have one parameter, s, which must be string based. This you can see from the context. Then on the right-hand side of your lambda expression, you convert this string to an uppercase version, and you return this string you calculated. So the return type is also a string. Therefore, now the func delegate have 2 type parameters. The first one is for the parameter s. The second one is for the return value. Let's check out the second example. Here we have 2 parameters, s and y. S and y, yeah, s and y. The first parameter is supposed to be a string. The second parameter is supposed to be an integer. But we also have to specify the return type as the third type parameter, which is a character if you look at the example closely. Okay, one more slide. This one. This is also an important delegate in the .NET framework. It's called predicate. Well, you learned about predicates in your logic course in the first semester. A predicate always returns a bool value, true or false. So in the .NET framework, the predicate delegate receives always only 1 parameter, as you can see here on the left-hand sides of the lambda expressions, and always returns bool. Here you can see on the right-hand side that everywhere a condition is used, here or there or there. Okay, we are going to use those 3 kinds of delegates next week. The predicate delegate, the action delegate, the func delegate, because they are widely used inside this cool technology called the LINQ technology. But I'm running out of time now, so here I would like to finish my lecture.